Welcome back to Advent of Code 2018, day 14. Hello, Nomad. So we are properly halfway through now. Just over. Those beer mugs. Alright. Yesterday, I did two problems. I thought they were pretty good problems. Can't remember what they were. Alright, we've got one. What's this? Looks like number theory, something like that. Chocolate charts. You finally have a chance to look at all of the produce moving around. Chocolate, cinnamon, mint, chili peppers, nutmeg, vanilla. The elves must be growing these plants to make hot chocolate. As you realize this, you hear a conversation in the distance. When you go to investigate, you discover two elves in what appears to be a makeshift underground kitchen laboratory. The elves are trying to come up with the ultimate hot chocolate recipe. They're even maintaining a scoreboard which tracks the quality score of each recipe. Only two recipes are on the board. The first recipe got a score of 3, the second 7. Each of the two elves has a current recipe. The first elf starts with the first recipe, second elf starts with the second recipe. To create new recipes, the two elves combine their current recipes. This creates new recipes from the digits of the sum of the current recipe's scores. Okay. With the current recipe's scores of 3 and 7, their sum is 10. And so two new recipes would be created. The first with score 1 and the second with score 0. Oh. So you sum the digit, Okay, you take all the current recipe scores, you sum the integers up to get some bigger integer, and then you add up the digits of that, and then the individual digits of that final number are the scores of the new recipes. Okay, so in general, you would. Okay, fine. The new recipes are added to the end of the scoreboard. Oh, so you keep the original recipes. Okay, so the list of recipes does grow. Fine. After all new recipes are added to the scoreboard, each elf picks a new current recipe. To do this, the elf steps forward through the scoreboard a number of recipes equal to 1 plus the score of their current recipe. So, the first elf moves 1 plus the score of their current recipe. So the elf that was looking at 3 now moves forward 4. Okay, fine. So, okay, this diagram might help. So we've got 3, 7. Then we introduce 1 and 0. And then the elves on 3 and 7 move to 1 and 0. Okay. Wait, what? No. Okay, so you introduce 1 and 0. 3 moves forward 4 times. The guy sitting on 3 moves forward 4 times. 1, 2, 3, 4. So he stays on 3. Same goes for 7. Then you introduce the new digits, which happen to be 1 and 0 again. Wait, why? Shouldn't it be 1 and 1? digits of the sum of the current recipe's scores. Oh no, current recipes doesn't mean... Okay, it means the two that the elves are sitting on. Okay, that makes sense. That's... Okay, I get it now. That's an easy process. The elves think their skill will improve after making a few recipes. 293801, that's how many recipes we have to make. However, that could take ages. You could speed this up considerably by identifying the scores of the 10 recipes after that. For example, if the elves think their skill will improve after making 9 recipes, the scores of the 10 recipes after the first 9 on the scoreboard would be those. After 2018 recipes, the scores of those. Okay, so you're waiting until you have that many recipes altogether. That's 293,000. Can we maintain that all in an array? Yeah. Yeah, sure. Why not? It's not too big. But we have to wait until the array's at least that plus 10, because we need to take the 10 after. Alright, this doesn't look... It's a bit wordy, but it doesn't look hard. We just have to repeat that process. I think the number is not too big, so we can just maintain one massive array of all the recipes until it's grown to 300,000. That's fine, we can do that, there's enough memory. I don't see any way of cutting corners, because you always could loop back through the array, so you need to maintain the entire array. There's no... I don't see any pattern, but there could be a pattern. But I don't think it'll be an easily predictable pattern. Okay. Let me just get my coffee and we'll get started. So, 14. All right. Oh, that's the minecart. There's always a minecart level, as I always say. Puzzle input. Alright, so let's just say num recipes. Is that how you spell res? I guess so, yeah. Was that? We start with what they've given us, so recipes equals 3, 7. Current equals 0, 1. So it's saying the two current elves are looking at recipe 0 and recipes 1. And that will update. So we have to... Oh, this is a bit zoomed out. Let me see if I can... Okay. So we have to repeat until length of recipes is at least num recipes plus 10. Because then we'll be able to get 10 after the first. Okay. Okay, so so we have to do the 2 steps of this process. Okay, so first, creating the new recipes. Okay, so we take res. Okay, so the sum S equals, so it'll be recipes current. So take the first current plus so that's the sum. Now we want to get the digits of the sum. So basically we say for character in the string version of the we convert it to a string, go over each of the characters, and recipes dot append, turn it into an int. So it'll just be a digit from 0 to 9. Alright, so that's phase 1. Then we have to update the current. So each current, so current equals, so current 0, shall I make this a list? Normally it's better practice to use tuples because it's dangerous to modify things in place, but we'll just do it the quick and dirty way. So current 0 equals current 0 plus 1 plus no plus yeah, recipes current 0. Okay, so this says the pointer, this pointer which is pointing into the recipes, is increased by 1 plus whatever the recipe is. So in this case it would be 4. And the same for current 1. But we need to modulo the length of the recipe so we don't roll off the end. Alright, so when that's done, scores of the 10 recipes immediately after the number of recipes in your puzzle input. So we want to print recipes from here to, so it's going to be num recipes to num recipes plus 10. Try running that. Can we, how do we, okay. Dot join sx for x in recipes. So join it up as a string. Oops, join. There we go. 31475741007. As it turns out, you got the elves' plan backwards. They actually want to know how many recipes appear on the scoreboard to the left of the first recipes whose scores are what? They want to know how many recipes appear on the scoreboard to the left of the first recipes whose scores are the digits from your puzzle input. How many recipes appear on the scoreboard to the left of the score sequence in your puzzle input? Oh, wow. So we basically, every time we add to the list, we want to see if we've made the string 293801. Okay, we can do that. In the past few characters. Okay, so reset this. Okay, so we do that again, but okay, we do while true. So we do that, and then after we've added, we're going to define a define score check. Off an array. So that says return true if the final array so it's going to be, let's say, n equals length of string of num recipes. That's how many characters we need to check. So we need to say array of -n to the end. That will give us an array of ints. Then we need to string x for x in, turn them into strings, join them up, and turn it into an int. If that's equal to num recipes, then it returns true, otherwise false. So it's taking the last n characters. So even if this is shorter than n, that will still be the last n. So it'll just be the last 2. So that will be false. That's fine. So we turn them into strings, join them up, turn that whole thing into an int, just to get the big int. All right. So each time we add a character. All right, we want to define a method here. Define get result. I can't think of a better name. All right, so while true, we do this. If score check of recipes, that means we found what we need. Then we want to return. So it's how many recipes to the left of the score sequence. So it's going to be length of recipes minus this, basically. Minus the actual sequence at the end. Let's try that. How long is that going to take? So we're going to keep going until we see that sequence come up. It's taking a while. There we go. Because, yeah, I mean, I can't think of any way of speeding this up or cutting corners. I think you have to... It's unpredictable, so you can't predict ahead of time what the sequences are going to look like. I think this is basically like almost like a number twister generator. So, just have to wait until it runs. Let's see. Correct. Okay, we're on to 15. Beverage bandits. Having perfected their hot chocolate, the elves have a new problem. The goblins that live in these caves will do anything to steal it. Looks like they're here for a fight. Goblins. It's pointing us to the Wikipedia on goblins. Cool. The Gap of Goblin. You scan the area, generating a map of the walls, hash, open cavern, dot, and starting position of every goblin, G, and elf, E. Are we playing Dwarf Fortress now? I mean, I bet that's even the correct letters. No, E is elephant, isn't it? I don't know what the letter is for goblin. For elf, I mean. Combat proceeds in rounds. In each round, each unit that is still alive takes a turn, resolving all of its actions before the next unit's turn begins. On each unit's turn, it tries to move into range of an enemy and then attack. All units are very disciplined and always follow very strict combat rules. Units never move or attack diagonally, as doing so would be dishonorable. When multiple choices are equally valid, ties are broken in reading order, top to bottom, then left to right. Okay. For instance, the order in which units take their turns within a round is the reading order of their starting positions in that round. Yeah, fair enough. Each unit begins its turns by identifying all possible targets. If no targets remain, combat ends. Then, the unit identifies all of the open squares that are in range of each target. These are the squares which are adjacent to any target and which aren't already occupied by a wall or another unit. Alternatively, the unit might already be in range of a target. I am a bit lost. What is the point in... Someone's doing karaoke again. What is the point in... Identifies all of the open squares that are in range of each target. I don't understand. We'll look at the example later on. Are we talking about only targets which are next to them, or...? No, all units of the opposite type, I guess. If you're a goblin, you look for elves. Okay. So you look at all the elves. If you're a goblin, you look at all the elves, and then you identify all of the open squares that are in range of each target. Why? But then what do you do with that? And then it doesn't seem to use that. Oh, I need to read on, probably. Okay, if the unit is already in range of a target, it does not move, but it attacks. Okay, fine. This is making sense. So you need to be next to someone to attack. So... if you are next to an enemy, you attack. Otherwise, you move. So to move, the unit first considers the squares that are in range and determines which of those squares it could reach in the fewest steps. But what does in range mean? Give me some numbers here. So range doesn't mean next to you. A step is a single movement to any adjacent open square. I think in range doesn't mean anything. I think in range just means they are some distance away. Oh, probably the map can be separated into different clumps, so... in range means accessible locations. Step is a single movement to any adjacent square. Units cannot move into walls or other units. The unit does this while considering the current positions of units. Current positions of units, and does not do any prediction about where units will be later. If the unit cannot reach any of the squares that are in range... They keep using these terms but not explaining them. It ends its turn. I assume it just means reachable. See, now they're using the phrase reachable. Do they mean, does that mean the same as in range? If multiple squares are in range and tied for being reachable. What? Okay, so clearly in range doesn't mean reachable. Then what does it mean? Oh my god, look how long this is. Alright, just carry on reading. Okay, so if multiple squares are in range and tied for being reachable in the fewest steps. Then you choose in reading order. Fine, makes sense. In the above scenario, the elf has 3 targets. Okay. So we've got an elf. And you've got 3 enemies. The goblins. Okay. Each of the goblins has open adjacent squares which are in range. Fine. So these question marks are the spaces we're heading for. In range means... I think in range is a meaningless term. It just means they exist. It doesn't mean we can actually reach them. They might be blocked off, but they exist. So they shouldn't have used the phrase in range. That doesn't make any sense to me. In range would suggest there's a limitation on how far you can go. Alright, so those are its where it wants to move to. 4 are reachable. These 4. The other 2 are not, basically. 3 of these reachable squares are nearest. And of those you choose the reading order. Okay, fine. The unit then takes a single step toward the chosen square along the shortest path to that square. If multiple steps would put the unit equally closer to its destination, the unit chooses the step which is first in the reading order. Okay. Fine. So all these G's move towards E. Yeah, makes sense. But does E attack? It probably does. Oh my god. Look at all this. This is complicated. Alright. So that's movement. After moving, if it moves, it then carries out an attack. Okay. To attack, the unit first determines all of the targets that are in range of it by being immediately adjacent. And then you choose the one with the fewest hit points in reading order. Okay, fine. The unit deals damage equal to its attack power to the selected target, reducing its hit points by that amount. If its hit points are reduced to 0 or fewer, the selected target dies. Makes sense. Each unit has 3 attack power and starts with 200 hit points. Yeah, I don't need to read this. Okay. The elves look quite outnumbered. You need to determine the outcome of the battle. The number of full rounds that were completed, multiplied by the sum of the hit points of all remaining units at the moment combat ends. Alright, so you start off with four goblins and 2 elves, so you'd expect the goblins will probably win. So after 23 rounds, you end up with this. 24, 25. This guy's going around. 27, 28. And then they carry on. 47. The elf dies. And as soon as there's no enemies, combat ends. Oh my god. What the heck? This is what we're dealing with. Alright, so it's not... There's no separate compartments. There's a strange little area here. So basically it's just lots and lots of breadth first search. But we have to break ties correctly, that's the tricky bit. Okay. This is a fair bit of work. Alright, we'll copy this in. Basically putting together a mini Dwarf Fortress game now. Just having a think about all the different things. So basically we want to... Okay, we store this map in a 2x2 grid with the letters and everything. And we have separate lists for all the units. Goblins and the elves. So we have a list for goblins, a list for elves. because that makes it easier. So then the goblins know where all the elves are. I could use A-star search to speed things up a bit. I think breadth first will be fine now. Because there is some kind of obstacles here, so it might help to use A-star, but we'll see. Well, let's put together some stuff. So we're gonna have to have a grid. Just an empty list. Okay. Line in f.read lines. Okay. Okay, so just put all the characters into the grid one by one. If... Alright, we want a list of goblins. We want a list of elves. So... we're gonna have to... Okay, for I... line in enumerate f.read lines. For J character in enumerate line.strip. This gives us the coordinates. If is G, then goblins dot append. So what do we want to store? Just their position and their hit points? I could make a class, an actual entity class, but I don't. If it's only their position and hit points, we probably don't need to worry about that. Okay, so we just put what coordinates do we want to use? I's and J's or X's and Y's? I's being rows. Doesn't actually matter which one, it's just I just need to stick with it. Let's say I's and J's. Since the problem doesn't specify any coordinate system. Alright. So I, J, hit points. Start with 200. Let's say starting HP equals 200. Okay. So let's make sure we've got stuff here. Yeah, okay. Now what? So we've got our setup. So basically we want to... We need a few helper methods. This is the dimensions of the map. We need define get neighbors of a position. Now we need to make sure we return these neighbors in the reading order. So it's going to be up, left, right, down. So for the So up will be -1, 0. Left will be 0, -1. Right will be 0, 1. Down will be 1, 0. For DI, DJ, that. So neighbors. Okay, so the new, new neighbor ij equals pos 0 plus di pos 1 plus dj. So that's the neighbor. If I is within that bound and j is within that bound, then we return that new position. We add to the list. Okay, so those are all the neighbors, excluding the ones that are out of bounds. So that's we're gonna need that method a lot, probably. What else do we need? We need a BFS method. So, given starting position and a goal, return the shortest path. No. Don't have to return the shortest path. Return the next step that will take us towards that path and the distance of that path. We'll need those two things. So the distance of the shortest path and the next step to take in the shortest path. Okay, so this is the crux of this whole solution. It all rests on this BFS method, so define BFS for a starting position and a goal. So let's just make a note. Get dist and next step in shortest path from start to goal. Should I say return none if no path? Okay. All right, BFS, fun. We need a Q. Q equals Q. Q equals Q. Q dot put start. Right, so we need a dist, which is going to be the distances to each node. Do we actually need that? No, we just need came from, which is a mapping from each node to which node you arrived from to get to that node. Yeah. All right. I'm wondering if because it'd be a different story if I used a priority queue. Then it'd be harder to maintain the reading order. Well, we would have to have reading order as a separate metric, which is a bit confusing because. But the good thing about using a queue is that you can put things in the reading order, and that will be maintained in the queue. If you use a priority queue, then it all gets jumbled up, and you don't maintain reading order. So you need the heuristic. If I was using Dijkstra. But Dijkstra is just BFS in this case. Dijkstra. Yeah, no. If I was using A star, that would be using the priority queue. Well, no, so would Dijkstra, but because the distances are 1 here, then it's irrelevant. Both the queue is equivalent. But if I were to use a priority queue instead of a queue, it would return the same result, except it wouldn't respect the reading order. That's the problem. Okay, stick with the queue. just say start does not have any came from. All right. Actually, we do need a dist. Okay. So that's the setup. For no. While not q dot empty. Get the next thing in the queue. Right. If current is goal. Hang on. We would know this already if we saw it later on, so... We don't need to do the goal check here. We would see it when we find the neighbor. All right, so current, we've got a current. We're now doing the step where we take a node. We want to find all the next neighbors. So for neighbor in neighbors in, sorry, get neighbors of current. This gets all the neighbors. If this neighbor is not a full stop in the grid, that means we can't go there. It's occupied. If grid neighbor 0, neighbor, some helper methods for getting from the map would be helpful here, but whatever, is not equal dot skip this neighbor. So this is a walkable space. So if we've already found out, if we've already visited this neighbor before, that means it's in the came from map. We've already found the shortest path to this neighbor before, then we don't try to start a new shortest path there. We've already found the shortest path. So if neighbor in came from, continue. So now this is a walkable space that we haven't discovered before. So that means dist of neighbor equals dist of current plus 1, and came from neighbor equals current. Okay. And now if this is the goal, Well, I don't know. Break out of that loop. But we need to know to... Alright, say is goal found equals false. Goal found equals true. Break. So then when we get here, so we want while not goal found and there are still, so while we haven't found the goal and there are still nodes to process, that's what we're saying. All right, finally, the normal operation is we just add this neighbor to the queue. So we say queue dot put neighbor. So this should give us the shortest path, taking into account we want reading order. I think. Is there anything that could trip me up here? I don't know. We're always taking reading order steps. I think it's correct. Okay. So now, when we exit out of this while loop, in either of these cases, if we didn't find the goal, if not goal found, return none, none. Alright, so we found the goal. We need to return the distance and the next step. Okay. Okay. Temp equals goal. While came from temp is not none. Temp equals came from temp. Alright, so what we're doing here is we're putting a pointer called temp on the goal, and then we're moving backwards through the came from map all the way back to the beginning. And we stop when temp came from temp is none. Well, no, that would make it start. Okay, change that. While is not equal to start. Alright, so we stop when we've traced our path back to start. Temp is now looking at the next step after start. So we return dist, goal, and temp. Is that good? That's BFS. That's the hardest part of this. Alright. Now what? See if that actually runs. Should we try printing... just try something. Let's say from... So we want BFS, let's say 2216 to here 1526. Try running it. Damn it. Alright. Key error 2216. Dist neighbor equals dist current plus 1. Ah. Well, we have to... Oh yeah, I forgot to put the distance for start. Okay, run again. So it's saying it's 17 away. That's probably right. I didn't really count. And the next step we take is 2116 from 2216. Is that right? So we were around there and we're going there. So we go up because reading order. Up instead of right. Makes sense. Yeah, sure. Okay. Alright, now what? While true. So we keep going until hang on. Until we get around where a unit cannot take its turn. Okay. So this is going to be a, let's say, from ITER tools import count. See, small c. Yeah. So for round in count. So if in the second round, which round will be the variable round will be 1 in the second round, and if an elf can't find a target, we break out of this for loop, and round will still be pointing to 1, which is how many complete rounds we did. So round will be the final answer. Print round. That's what they want, right? No, something they want. They want some calculation. Okay, well anyway, we can deal with that later. For round and count. Okay. So, oh man. So units equals goblins plus elves. Goblins. So regardless of... So we process them in reading order regardless of whether they're goblins or elves. It's not like goblins act first or anything. Okay. You know what? I think we should make this a list. Reason being, when we go through these units, if we want to change their position, we simply modify ij, and because this unit will be maintaining a reference to that list rather than making a new copy, it will actually modify the position in the original goblins and elves lists, respectively. Yeah, I think that's the way to do it. So what we want to say is, for unit in sorted goblins elves, and it's going to sort them according to their position and their HP. And because I've done position like this, it's prioritizing I first, then J. And there's never any ties because there's unique positions, so that should be fine. Yeah, okay. So for unit in sorted, keep putting goal bins. Okay. So for unit in sorted goblins plus elves, so we have a unit. Okay, so first we want to see what kind of unit he is. So if let me be completely clear on this ending condition. So if has no targets. Okay, so if there's no enemies existing, regardless of whether you can reach them or not. Alright, so if grid... Okay, let's unpack some stuff here. Pause HP equals unit. If grid pause 0, pause 1. Okay, so enemies equals elves if they are a G. Else E. So we want to know what their enemies are. If they're a G, then their enemies are elves. Oops, else. Okay, goblins. There's one thing I've realized. If we've moved units earlier in this list, we could actually kill units later in the list. And if we do that, then they're dead. So we don't want to remove them from these lists until the end of this, because otherwise we make things all confused. I don't know. Let's say if HP equals 0, if this comes up, then we continue, because that means we're dead. We're not allowed to act. It depends on how we're going to handle this. But either way, this is a safety net. So if we're dead, we can't move. So because some earlier units might kill later units, then when those later units have their turn, they should skip their turn. But yeah, because here this is making a copy at that point in time. So we might actually delete things from goblins and elves, but that copy will stay fixed. Okay. So we worked out what the enemies are. So this is where we want to break out of the round. So we want to say done equals false for round and count. Right. If not enemies, we have no enemies. Done equals true. Break. And outside of this for loop, if done, break. That stops us from... That makes sure we complete rounds. We're counting complete rounds. So if done happened during the round, we break so we don't get to the next round. We don't want to check that done at the beginning, for example. And we don't want to check it in this condition either. We want to break out of it abruptly to stop getting to the next round. Alright. Okay, so if we've reached this far, that means we have enemies. So we have to do the movement phase. We need to choose the closest... Okay, movement. So what they said was we choose all cells which are adjacent to all the enemies. Alright, so we've got a set. So we've got target equals set. This is the same vocabulary that they were using. Targets. No. No. Targets was enemies. Let's use the same terminology here. They said in range. Okay. In range equals a set. So we want to accumulate all the adjacent cells to our enemies. For enemy in enemies, for neighbor in get neighbors enemy 0, so that's their position. If grid neighbor 0 neighbor 1 is an empty space, then in range dot add neighbor. Okay, so that's taking all the empty spaces adjacent to enemies. Okay. Now we have a list of in-range cells. Now we need to find which of those are reachable. Oh man. See, I don't think. I think BFS. We actually would want to. Give a list of goals. A set of goals, not one goal, because otherwise we're rerunning BFS many times just for each goal. That's really inefficient. Let's change this. BFS execution. So BFS goals. If we hit any goals from this goal set, and goal is a set. Goal set. So when we use goal, if neighbor in goal set, goal found equals true, blah blah blah. Then that's the first time we found Alright, goal found is not going to be a boolean. Instead, we'll set it to none. And while goal found is none, and not q.empty, goal found will be neighbor break. Alright, if goal found is none, that means we never found anything. Return none. Alright, now temp equals goal found. Return dist goal found temp. Okay, now we're using a goal set instead of a goal. That cuts down a massive factor. No having to run BFS a million times, just run it once and we keep going until we find a goal. That is a massive optimization. If I didn't do that, probably it would take too long. Okay. Okay, back to this. So we have a list of in range. That's our goals. So we want to get dist and next step. Dist next step equals BFS from pos and so, Why do we want the dist again? We don't. We just want the next step. Get next step. Okay, just simplify this. So we don't ever use dist for anything. It's just came from. I'll keep this just in case, but yeah, we just want temp. Okay, so next step equals BFS pause in range. Also, at the start we can say if not goal set, return none. If there's no goals, then turn none. Right, so if next step is not none, then we move. Otherwise, we just go on to the combat phase. So next step is not none, so we simply move, right? Unit so we update the pause. Pause equals next step, and we have to update it in the data structure. Unit 0 equals pause. And as I understand it, this will update in the goblins and elves lists as well, because we're holding a reference to a mutable variable here, the list. So unit 0 equals, so we're updating its pause. Maybe we shouldn't unpack this. We should say if always use the reference to the unit. That way we don't risk using outdated information. Always use what's currently up to date. So unit 1, that's the HP check. Pause. So pause is going to be unit 0. Okay. Then we do this. Unit 0 is next step. Alright, that's movement done. Combat. So we may have moved, and that should now be reflected everywhere, which is relevant, including goblins and elves. So now we do combat. Alright, well that's all movement. Attack power is 3. Let's make that a variable. combat. Alright. So now we look at our neighbors, and if one of them is an enemy, enemy symbol, let's say. Oh, if we move, I forgot this. We have to update the map. Grid. Okay, so we need to know our symbol. Grid. My symbol equals grid equals this. So it would be G or okay, my symbol is that. Okay, and that's stored. So now, when we take this step, we have to do grid. It used to be G or E. Now we change it to dot because it's empty. We've just taken a step. Then we update our position to be the new position. And now in the grid, we change that place to our symbol. All right, that fully keeps everything up to date if we move. Don't think anything else needs to be changed. That changes the grid as well. All right, combat. Okay. Enemy symbol equals E if my symbol is G, else G. All right. For neighbor in get neighbors unit 0. So for all of my neighbors, and if we find one, then we'll break out of this. Okay, so if grid neighbor 0, neighbor 1 is enemy symbol, then we have to carry out the attack, and then we have to break out of this loop. All right, so the attack. We don't have a clean way of doing this. Okay, what we need to do is we have to look through the enemy list, find the place, find the enemy. Unless if we had a hash map, we could do this, but let's just do it the slow way for now, and I can improve this if need be. Hash map. Okay, I'll make a to-do. Just in case we decide to make that optimization. I don't think it'll be too slow though, because there's only like a few units. It's not that many. All right. So if it's an enemy, we need to for enemy and enemies. If enemy position is the same as neighbor, that's the enemy we want. Break. Okay, so we've found the enemy we want. We know it exists because it's there in the map. We look at the enemy and we attack them. So enemy HP minus equal attack power. So it's now it could be negative or 0. This is weird. Okay. Let's hold a reference for I enemy in enumerate enemies. We want to hold a pointer rather than a enemy. I don't understand how this works really. Safer to use a pointer. Alright, so enemy, we reduce their attack power, we reduce their HP. If enemy 1 is now less than or equal to 0, they're dead. We need to delete enemies. So this is another thing which is inefficient because of the list instead of hash map. Delete enemies I. So we kept the pointer. That way we can safely delete from the enemies list because we're no longer holding it, holding a reference to it. Whether or not they die, we break out of this for loop so we don't attack someone else. That's the combat phase. That's when we do done. So if we've done all of that, round is now telling us how many rounds it was. Completed rounds. So the outcome we want is full rounds multiplied by the sum of the hit points of all remaining units. Okay. Okay, so outcome equals round times sum of unit HP, so that's 1, or unit in goblins plus enemies. Goblin plus elves. If they've got negative health, they should have been deleted from this list. If they weren't, then this is going to mess up this sum, but whatever. Yeah, that will help us identify a bug anyway. Round, that's fine. Print outcome. Okay, that was one massive program that I never bothered to test. Let's see if it actually works. Bloody hell, okay. Run 15. 25520. I mean, the fact that it actually terminates is a good sign. That means elves are actually dying, or goblins are actually dying. Who do we think is going to win anyway? Goblins are going to win, clearly. Way more goblins. Those elves are overwhelmed. And then these goblins will come down and fight these guys. I'm surprised it ran that quickly, but we're working with a small map and there's a choke point here. So when these 2 steps get filled up, then these guys won't move at all because they can't find a path. Or they can come down here as well, but it should all work out. My only worry is the whole reading order thing. I don't know if I've done that correctly. Alright, 2552, let's try it. God, that was a long problem to code. Fuck! Too high. Alright, now we've got to debug. Okay, but I mean, they've given us a good example, so... So this is the example of the movement. Should I switch to using that hash map first of all? Because that also will prevent errors. I think that's probably better. Alright, let's do that. Okay, so... Goblins equals hash map. Elves equals hash map. Okay, so it'll be goblins IJ equal... Wait, how am I going to do this? Just say it just maps to their HP. Right, so goblins and elves maps a position to their HP. That's all. Okay. Get neighbors, yep, that's fine. Alright, so, BFS. Alright, so here. Sorted. Goblins. Okay. So instead of this, we want for, let's say, for unit pause in sorted goblins dot keys plus elves dot keys can't concatenate them. Yeah, okay. Just, I don't know, just do list. I know there's a way of doing that efficiently in sorted, but whatever, doesn't matter. So for unit pos, amongst all the positions of the goblins and the elves. Alright. If... Damn it. Okay, hang on. Alright, first we need to figure out who the allies and the enemies are. So, let's do this. Allies equals... It's basically this, so... Goblins, if... Okay, and my symbol... is this... Right, my symbol is... that. Whatever's in the grid. So if it's G, our allies are goblins, else elves. And if it's G, our enemies are elves, else goblins. That way we know where we lie. Alright, so... if... allies... unit pos... is... less than or equal to 0 for some reason, we'll continue. We're dead. But we'll also print... error... dead... unit in... list. Just print some data if we can. Unit pos. Figure that out if that ever comes up. If not enemies, done equals true, break. Okay, so allies, enemies. Right, so for enemy and enemies. For neighbor and get neighbors. Hello, non-toxic guy one. You're making the same if statement twice. I think you can do allies, enemies equals allies, enemies equals, what would I do? Oh, like this. Yeah. Suppose that is actually more concise. I think we need to wrap these up. Yeah, that's fair enough. Also, welcome, non-toxic guy. Do you do Advent of Code as well? Ugh, karaoke is still going on. Sorry if that's coming through on the mic. Right, what now? So we're gonna use unit pos here. Unit pos. No. Stop. For enemy and enemies. Okay, no, hang on. Enemies are hash maps now. Okay. So for enemy pos in enemies. Do that. For each of his neighbors, We add the neighbor to the in-range set. Okay. Next step equals BFS from unit pause using the in-range set as the set of goals. Alright, so if we find the next step, then grid... Okay. So it's different. Oh, okay, so let's update the grid first. Yeah, I know a bit how to code. I'm a Unity refugee. It's that time of the year again for Unity refugees. Well, not every year, but a couple of years ago there was a similar situation with Unity. I can't remember what it was. Another pricing thing, licensing thing, which caused people to migrate. This time it's worse though, definitely. Okay, so... Oh, I need more coffee for this. This is the tough part one. Just tough in terms of the amount you gotta write. Not in terms of the concept, but I haven't got it right yet, so that's also maybe a problem. But, okay, grid. So it'll be unit pause 0. Unit pause 1. So where we were standing, we set it to dot. And then we want to let's say my HP equals this. Okay, so we've got my HP. So we're gonna say allies next step equals my HP. So we're storing this unit in a new location. The new physical location. We delete the old location. Delete allies unit pause. So this is safer than what I was doing with that list. Because we're deleting key value pairs from the dictionary, which is not shifting stuff around in memory. So it's more efficient and safer. I would say both. Both more efficient and safer. Take that out. Unit. So delete the old position. Update the grid. So we want next step to be my symbol. Man. I need to... I mean, if I were doing coding game, which is a site where you do these kinds of things for real games, I would definitely make more methods here. Like grid would be a class, and grid would have helper methods for getting locations, adding, updating, all this stuff. Because this is kind of not reliable. Well, we'll see if it works. So, and at this point, we will want to update this variable to be next step. So at this point, unit pause is either updated or it's not. Okay, so we can continue using unit pause. So for each of its neighbors, if the neighbor is an enemy, so we've done this. Okay, we don't want to do this. We want to say enemies neighbor minus equal attack power. So we firmly know that it's in that map. if it's now dead, we want to delete enemy's neighbor. Is that safe? Am I allowed to do that if I'm not holding this point? If I'm holding this? Yeah, should be fine. And we want to break out of that loop so we don't hit anyone else. If done break. Okay, let's see if this gives us the same answer. 245520. Okay, we got a key error. Enemy's neighbor, subtract attack power. So for some reason, we saw an enemy symbol in the grid, but that grid location for some reason is not in our enemies list. How could that happen? That can only really happen in this step here, because this is the kind of the atomic operation where we update both the grid and the unit lists. Have I done this right? Well, is that definitely what happened here? Key error 619. Yeah, so it's saying it can't find this neighbor, but the symbol another possibility is if we delete, this is something we never did. If we kill an enemy, we also have to update the grid. We didn't do that. There's two places you update the grid. One is if you move, one is if you die. So this is the second. This could be the problem then. Maybe. So grid, neighbor 0, neighbor 1. We change to a dot because he's dead, and then we delete him from the enemies. Statement seems to have no effect. Oops. Grid, neighbor 0, neighbor 1. Why doesn't it like this? We've done it here. I think it's okay. It's a bit. I mean, we were able to do it here. Why doesn't it like it now? If it's enemy symbol, then I think it's just it doesn't understand because we're kind of we're not really modularizing it very well. Okay. Key error. Now we've got a key error here. My HP equals allies unit pause. So we've got a unit pause. We found its location in the grid. No, we've got a unit pause that we found amongst either goblins or elves. We used the grid to determine whether it was an ally or an enemy, but then for some reason, unit pause is now not in the respective list. What the heck? So he's an enemy, but does that mean we've got the wrong symbol? My symbol. Did I use the right symbol? My symbol is whatever's in grid. Okay. Allies equals goblins. If we're G. Elves. If we're not, otherwise elves, goblins. What? 2418. So that's definitely a key that's amongst goblins and elves. That's really weird. Why has that happened? We've got a goblin masquerading as an elf, or vice versa. That's an odd error. Oh. Ah. If a unit dies, its pos is still going to be called up here because this list is static here. So this my HP thing doesn't make sense anymore. Take that out. Instead, if it dies, that means unit pos is no longer in goblins or elves, and the respective grid location should be showing a dot. So here we say if my symbol equals dot, that means we're dead. Continue. We don't need to do this HP thing. Let's try it now. Oops. What now? Sum of okay. Sum of HP for HP in... No, it's okay. We're basically summing goblins dot values plus elves dot values. That's the HPs. Summing them all up. Oh, it's not gonna like that, is it? Because there was a... okay, whatever. List. Cast those to lists. I'm sure you could... I don't know. There's some concatenate method. 275655. Wait, isn't that the same as we had before? No, it's not. Okay. Damn it, but they said our answer was too high. And now we've got a higher answer. Alright, well, I'm sure I've fixed things, but now we've got problems. Whatever, I'll try that number just in case, but I mean, they said it should be lower, so... Wrong, okay, fine. Oh man, alright, let's print the map, see what we're dealing with. Pretty hungry. This is a really lengthy problem, okay. For row in grid, print join row. I want to see what it looks like. That's the map. We've got a bunch of G's floating around. They've killed all the elves. So I mean, this is a good sign. This is a sign that they're actually doing mostly what they're supposed to. And if we look at what the original input looked like, does this make sense? So these G's... No. No, this doesn't make sense. Where did these G's come from? This E probably went up and left. These G's came down. But this E wouldn't make it all the way here, would he? So yeah, there's no reason the G's would go here unless... Yeah, something's wrong here. There's no reason a G would come here unless an E were to be somewhere in this section here. But an E would never go to that section because there's always a goblin out here. Alright, so that's a problem. So we've got something wrong with our pathfinding. This part looks about right because they're gonna get bottlenecked, and then as soon as a G is blocking the path here, no one else wants to go through. That makes sense. They do, I mean, the elves do die, so that's kind of plausible. The fights seem to happen where these Gs ended up. That also makes sense. I just don't understand what these Gs are doing. If there was an elf down here, these Gs should have come down. What are they doing? Alright, well, we've got lots of debugging to do. How many rounds was that? 115. Doesn't look right. We could actually print every turn. Do that. Alright, so this is every turn. Alright, so they start off roughly where they had begun, that's correct. And these guys are all going for this E, that's correct. This E moved to the left because... No. He moved up left? That doesn't seem right. See, his optimal move is up, because that's closest to the G. I can't see any situation where he would move left. Yeah, this doesn't look right. Something wrong with the BFS then. Everything else, that E goes up. That's probably wrong as well. He could have gone left. Well, no. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. No, that's correct. That E went to the right. That G went to the right. That's correct. But then the E went up. Okay. They're picking the wrong directions. What about down here? These E's went up, that's correct. This E went left, that's completely correct. This E went down, which actually is correct, yeah. Because that G is on that level. No. Why would it go down? He would go left, surely. It's up, left, right, down is the order of priority, so he should have gone left. Yeah, he should... Damn it. So the general problem seems to be that they're not picking the right directions. The next steps. But they're also not even picking the shortest paths, it seems, because there's no way he should have gone left. He should have gone up. Unless... How have I handled the case where we start? Hang on. Oh, I think I've not correctly handled the case where we actually start in one of the goals. Let's have a look. BFS equals start goal set. If not goal set, return none. Alright, let's do this. If start in goal set, we're already at the goal, then just return none. Technically there is a shortest path, but it's a null path. We don't go anywhere, so let's just return none. See if that gives us a different result. No. Well, where do they go now? E still went left. If start in goal set... Oh! Hang on. Yeah, because we didn't include our current position in the possible... Ah! He's trying to go to any location which is not our current location. That's flawed. Staying put is also a valid move here. Alright. In range. So if... For enemy pause, for neighbor. If it's an empty space, or... Or... Neighbor is where we're standing right now. Then we'll count that as well. So staying put is a move. Alright, let's try that. Much lower number this time. And does it move correctly? He stays put. And probably attacks. Yes. So what we were doing was, if we were next to an enemy, we were always moving away. Which is extremely problematic. Because that means our combat, they keep moving away, and they only attack if they move towards an enemy on that turn, and then attack. But if you start a turn standing on next to an enemy, then they move away. That was a massive flaw, and costing us extra steps. Does the final map look sensible? Yes, all those G's which are clumped over there have gone away. I don't know why that bug led to that issue, but whatever. Oh, because the E was next to enemies, but he kept on trying to escape, going away. So he kept going left and up and left as much as he could. Wow, okay. What was the result? 180,000. Alright, please, because I want to eat. And we haven't even got to part 2. No, it's too low. Well, that was definitely a bug that we fixed. A massive bug. Alright, let's have a look at this first turn then. So the final turn... Yeah, looks correct. Okay. First turn. So this E moves left. This E comes out. Why is that G? Oh yeah, no, that G. Okay, yeah, that's fine. Yep. What the heck? This... Oh, no, that's fine, that's fine, that's fine. This G comes down, yep, that's right. This G goes right. He would have liked to go up. But he couldn't because that G was standing there, so he went right. That's correct. These E's... Oh no, wait. This doesn't look right. No, that's correct, yeah. This G went up. No. Hang on. Yep, that's fine. He goes left instead of down, that's correct. And then this G comes up instead of right, that's correct. It's choosing the right reading order. This looks... These moves look good. What's happening? Let's go down a few. So then we've got this situation here. We've got these fights happening. That looks about right. So we've got these guys like this. And then next turn... Yep, they're still standing there. That's correct. Wait, what's this G trying to do? He's trying to go... closer. So he goes right first, that's correct. Then he goes down. And then he goes right. Then he goes right. It looks so good. What's the problem? So 64 rounds took place. Full rounds. Are we using the right variable here? Could it be 1 off? So round starts at 0. Oh. There's one... Hang on. There's one obscure situation which can happen here. If an enemy is killed on the last turn, we count that as an incomplete round. But I think that should count as a complete round. Alright, I think there's a way to make this a bit better either way. Okay, we say, don't use that. Let's say define get rounds. Do this whole thing. Get rid of this. Get rid of, don't do that for now. Don't do that. For round and count. Okay, so if we get to this bit here. If there are no enemies, don't do this. Do return. Let's strengthen this and say return round. Okay, so also we shouldn't use round. That's actually a Python method. Oh no, math.round. Whatever. Num rounds equals get rounds. Or round. Yeah, okay, that's rand. Is that safe? Okay, use that instead. Let's try that. I think there was a weird situation where 180096, was that what we did before? No, it's the same as before. Okay, that weird situation didn't come up, but well, we fixed that. Alright, what next? So we're saying have we got the order absolutely correctly? Get neighbors. So it's up, left, right, down. Yeah, that's right. Well, this is going to be a pain to debug. Starting, okay, have I got the right values as well? 200 to begin with. 3 HP per attack. Yep. Alright, let's test one of these examples then. Okay, use this. So, just clean this up. Alright, this is a simple example. So we end up with elves winning in those positions. That's exactly correct. 35,532. Wrong. Rounds 36. Wrong. It's 37. What? Full round. Why am I one off? That's probably my issue then. I'm just one off. Am I... Ugh. You hate it when this happens. Get rounds for round and count. So if... Where does count start? Zero. Yeah, it should be zero. Let's just try. I've used it before. Round. Break. Okay. Zero. Yeah, it starts from zero. So if... not enemies, then we return here, because that was one incomplete round. Wait. Do we sum the HPs at the... Wait, do we want the HP... Oh, we don't want the current HP. We want the... No, we do want the current HP at the moment that combat ends. Number of full rounds that were completed, not counting the round in which combat ends. I feel like I'm doing this correctly. How am I getting one off? I could just add one, but I want to know why. So they say combat ends after 37 full rounds, and I'm saying it ends after 36. After 36 full rounds. So for example, if we only do one round, full round, so to start off with, round will be 0. We do all this. Okay. Then round becomes 1. And then we see that we break out. So we return round. So we return 1. Isn't that right? Alright. I'm gonna have to print stuff, see what's going on. Print. So we're printing rand for each turn. Okay, so there should be 36 turns. Let's check that they match up. So after 0 full turns... Wait. Alright, let's just change this. Round +1, because we want to see what it looks like after full turns. Okay, so... Alright. 1. After 1 full turn, this is what it looks like. Does that match up? Oh no, they don't show. They just show the final answer. Well, that... Okay, so that looks right. E moved up towards the G. Those E's are blocked. So they stay put. Fine. I can believe that. 2, 3, and then we go down to 36. 36, it looks like that. And they're saying... Right, how does death work? Maybe death comes at the end of the round? After attacking, the unit's turn ends. Regardless of how the unit's turn ends, the next turn in the round takes its turn. The next unit in the round takes its turn. If all units have taken turns in this round, the round ends and a new round begins. It doesn't explain how killing works. What actually happens when you die? Let's have a look. 24, 24. Not counting the round in which combat ends. Don't understand. Combat only ends when a unit finds no targets during its turn. So they don't actually tell you what killing means. That needs explanation. The selected target dies. It's okay. Here we are. The selected target dies. Its square becomes dot, and it takes no further turns. So, if we've got a bunch of E's and there's a G, these guys take their turns. This guy kills this G. That G loses its turn. Then that E takes its turn. There's no targets, or are there? Let's have a look at this again. If not enemies, but there should be, there's okay, that's, then we return a number of complete rounds, so we don't count 36. Don't understand. So 36 complete rounds have taken place. and the map looks like this. So in round 37, each of these guys take their turns. I'm starting to think... Let me have a look at their example again. I think... Oh, hang on. Before the 48th round can finish, the top left goblin finds that there are no targets remaining and so combat ends. I think the question is ambiguous because it doesn't... They've never actually given a full example. They just give these snippets of examples, but they don't actually show exactly what happens when a unit dies. I still don't understand how death is, because there's a phrase here they use. Okay, regardless of how the unit's turn ends, the next unit in the round takes its turn. So that would imply to me that even if they killed successfully, I don't know. So, I don't know, apparently we're one off. I'm not sure if I even agree with them saying 37 instead of 36, but let's say they're right. Let's see if this is what the problem was. So it'll be, if we want to add one. Don't debug. Just run normally. That'll give us 36519. Is that right? 3, 6. That's still not right. The HP is wrong. What the heck? Alright, we're gonna have to have a look at the HPs then. Print goblins dot values. Goblins dot values. Print elves dot values. So the goblins have no health. The elves have this much health. Is that right? No, it should be... Okay, so we've got 200, 83, 104, 200, 200, 200. We've got too many elves left. What the heck? But, okay, I'm saying we've got 6 elves left. And there are 6 in the map. Oh no, we don't have the same final position as they have. There's an extra elf. What the heck? Okay, so it was actually wrong. There's actually wrong logic, so the round is not really the issue. We're gonna have to go step by step and see what's happened then. This is still part 1. I don't think I can... I gotta go eat and stuff. I think we'll just have to continue this next time. I don't like leaving mid-problem, especially mid-part 1, but... I mean, now that Okay, I think if I just go through this... It's only 36 steps, so if I go through this step by step, look at exactly what our HPs are, do it by hand, we can work out what's gone wrong. And I think if I do this next time, that I'll have a fresh mindset. So let's stick to using rounds, not rounds plus 1. Yeah, okay. Yeah, next time we will after each round I'm guessing the error is something as basic as just taking a wrong directional step that could result in because one was one additional elf. That means my elves did a better job. They're more efficient, but they're too efficient at killing. They probably shouldn't have been. So one of them has taken a wrong step, but it ended up being a step in which killed the goblins faster. Am I definitely handling death correctly though? So I've said return rounds if there's no enemies. That's fine. That's correct as it stands. My HP equals allies unit HP. So we're saying if my symbol equal... Oh, hang on. There's a very strange thing which could happen. Oh. How do we handle this? Okay. What could happen is a unit could die before he gets his turn. Then another ally walks into the space he used to be standing in. And then we get to his turn. But what happens is we give that other unit a second turn because he's now occupying his space. So we can't actually uniquely identify allies by unit pos. We actually need to do what you would do if you were making a real game and identify units by their unique ID numbers. That's what we need to do. That's the only way, because is there any fast way around that? Yeah, because you don't know what could have happened. Some other ally could have moved into his space, and then you don't know if that ally was the same ally or not. That's probably what happened. And I say it's a weird thing to happen, but it's so realistic for that to happen. As soon as an ally dies, there could have been another ally waiting to get there, and now he steps in. Alright, so how do we handle this? We have to use ID numbers. I think it's about time we start using a class for a unit instead of this. What we're doing. So we make a unit class. The class contains its position. His symbol, might as well. His HP. We store those classes in a well, see, we need to be able to look up enemies by location. So we store it in the hash map as we've done. But oh wait. Or maybe we instead of yeah. If we use classes, then we will be safe here. All right, I think I can do that quickly. I stopped the music. Keep the music going. We might be able to finish this. All right, let's define no, define a class which is a unit. Define unit. So we're given an initial position. And let's say symbol. And HP. Hang on, there's something special for this. What's it called again? It's static class or something? No, no. Oh, what's it called? Let me look this up. Data class? Yes, it's this. Let's use data class. This will be an excuse to use data class. And class unit. How do you use data classes again? Ah, like this. Hang on, so it's going to be class unit, so pause, so let me just Google a quick recipe for this. Name, okay, I get it. So we want pause, which is a tuple. Symbol, which is a string. HP, which is an int. That's all. Python does the rest. Okay. So okay, so then we can still do it as we've done before. So we do if character equals G. So we want goblins. So yeah, like this, but instead we do unit IJ symbol HP. We don't actually even need to store the pos in the unit, but I'll do it anyway. Symbol is going to be G. HP is going to be starting HP. Okay. So now we're using that. So now, when we unpack this, we've got 4. Now we do unit in sorted. So this is all the classes, and this is all the classes. But we need to sort according to a key. Key equals lambda unit, maps a unit to unit dot pos. So this sorts them by their pos. Alright, now my symbol, we know the symbol, we don't need that. So if this unit is dead, that means he's not in the map, but he still exists as a class. We're still holding a pointer to him, but his HP is 0. So we say if unit.hp is less than or equal to 0, continue. He's dead, he doesn't take a turn. But he's not. It's not a problem that he exists. HP is fine. Because he's not in the grid, and he's not in these. He's no longer in these lists. Okay, so if he's dead, continue. All right, don't need that. All right, allies, enemies equals. All right, fine. Don't need this. All right. Allies. I don't think we ever need allies, do we? Oh, we do. Yeah, we do. Okay. Allies, enemies equals goblins if unit dot symbol equals G else elves goblins. Fine. If there are no enemies, return run. Okay, that's good. All right. So now we do unit dot pause. Whenever we need its position. All right, now this step is important. We need to double check this. If we're taking a step, we update the grid for where it used to be. Let's do these together. We update the grid for where it is going to. So that's going to be unit.symbol. Actually, hello, Mara. Yeah, I got this. This is a really long-winded part one, but I'm getting there. It's almost like I'm coding Dwarf Fortress, but a micro-scale Dwarf Fortress. We've got elves and goblins killing each other in a battlefield. All right, so we delete its old position from the grid. We delete, remove him from allies. And now we update his position. And now we undo both these things. So we say equals unit.symbol. And allies unit.pos equals unit. Alright, so that is all that stuff. And HP doesn't play a role here. Alright. Combat. Enemy symbol is E if unit.symbol is G. Yep, that's fine. For each neighbor in the pause, goes enemy symbol. We don't need enemy symbol. We can say if. Oh no, we do need enemy symbol. Enemy's neighbor minus equal attack power. Ah, okay. So we do enemy's neighbor dot HP. All right, so remove HP, and now if he's dead, then grid will be updated to an empty space where he used to stand, and we delete him from enemies. The unit will still exist as a class, it just won't be held, it will lose the reference to it, that's fine. So if we kind of use him later on, we'll see that his HP is 0, so we won't do anything with him. But he won't appear in future iterations because he's no longer in these lists, so this seems safe. Okay, don't print any of this stuff. Alright. Oh, wait. We need to fix the HP thing now. So it's going to be... So it'll be... sum of unit.hp for unit in all of those goblins and elves. Don't need to print these for now. Print. Okay, I don't know. Try running it. Of course, there's an error. Here. Tuple object has no attribute pos. Tuple? Yeah, that should be values. Alright. Now... 35532? No. But we might be getting closer, I don't know. No, we still have an extra elf alive. That's not good. But anyway, we fixed another bad bug, so... delete enemy's neighbor if he's dead. So at that point, he should no longer be in the enemies, so no one else will try to attack him or be blocked by his presence. If we pull him up on this list, we'll skip him because he doesn't have HP. If we and now if enemies is empty, oh man. Now what was the problem? So we've got E, 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 E. That is not correct. But we've got one extra E sitting here. Whereas in the example, one of those E's died. Print print HP for E.HP for E in elves.values. I want to see what that HP looks like. 200, 83, 104, 200, 200, 200. Same as before. Nothing changed. Even though that is a necessary change. Oh my god. I think the problem then is something simpler, just like they're taking a wrong step. N is length of grid, M is length of... It's just the most important thing is updating grid correctly, because... So if we kill an enemy, we change grid to a dot. That sounds right. If grid neighbor, then enemies neighbor.hp, remove him from the enemies. Sounds right. Then break. So we're attacking... Oh no! There's one catch here. You don't attack... I forgot one thing. You don't attack in reading order. You attack the guy with the lowest HP. Okay, this might be it. This might be the problem. Alright, so here... we are attacking the person who's the topmost and the leftmost. It shouldn't be that. We should be... the one with the lowest HP. Okay, that's good. So let's see. Let's say attack targets equals empty list. For each neighbor, if that grid has an enemy symbol, then we put attack targets dot append neighbor. That's it. All right. If attack targets, so if there are no attack targets, then we carry on. Then we pick the minimum. So best target equals min of attack targets, key equals lambda pos. So a position will map to enemies pos. So we want the tuple. So it'll be the enemies pos.hp. So we attack the guy with the minimum HP, followed by the pos. So if they have the same HP, then we prioritize the pos. So they always go for the weakest target, the target with the lowest HP. Then we do all this stuff. Okay. Best target. Enemies. So we reduce their HP. If they are now dead, we don't need a break here. Grid. Then we replace the grid with an empty space. We remove them from the enemies list, and that's it. Wow, okay, let's see. 36334. And 37. Yes. Okay. Now we test the big example. There we go. Come on. I mean that's instilled a lot of confidence now, because those were some major bugs. That's what the final map looks like. Looks good. All the elves are dead. 184206. Nice. Should we read part 2? I don't know if I want to do part 2 right now. According to your calculation, the elves are going to lose badly. Surely you won't... I'll read it, but I don't know if I'll actually start it. But surely if you won't mess up the timeline too much, if you give them just a little advanced technology, right? You need to make sure the elves not only win, but also suffer no losses. Even the death of a single elf is unacceptable. However, you can't go too far. Larger changes will be more likely to permanently alter space-time. So you need to find the outcome of the battle in which the elves have the lowest integer attack power. So I can change their attack power. that allows them to win without a single death. This is not hard. We just need to try each attack power one by one, starting from 4. Until we win without a single death. We just need to change the data structures so that because we're mutating our current data structures, that means we can't reuse them in the future iteration because we've killed off some elves, we've changed their positions. So we need to... Oh man. Do I want to do that now? How much work would that be? Not a lot of work. If we just read the input from scratch over and over again. Alright, let's try and do part 2 now. Instead of... Okay, yeah, we'll just read the input. So, that was part 1, basically. Okay, so we've read the input. Let's define refresh grid. Does this. So whenever we want to refresh the grid, we have to redo these. So that will just create a new fresh grid, put everything in straight from the input. New goblins are created with their with the starting HP of 200. So we want goblin, so let's say G attack power is 3. And there is no elf attack power. We're gonna use that later on. Okay. Thing is, what I'm doing now is gonna mess up part 2. I'm not bothered at this point. Part 1. Not bothered at this point. I don't need to write code which can do both, one after the other. Refresh grid does that. Okay, so we'll refresh grid once. So num elves equals length of elves. That tells us how many elves there are. We need to not lose any. Okay, so get rounds for a given elf attack power will use that attack power. So every time we use attack power, we need to now use the correct attack power. It will do all this. And then when we're done, we say true if num elves is the same as it was to begin with. I.e., we didn't lose any elves. Return. So we don't want that. We want length elves is the same as num_elves. And it doesn't matter even if the dwarves win, the goblins, dwarves, because that will just cause this to be false. We want to keep increasing attack power until it's true. Now, where did we use attack power? Down here. Okay. Enemy's best target. So we minus Gobble G attack power if unit dot symbol. No. Yeah, if unit dot symbol is G, else elf attack power. Actually, I'd rather call that E. What do they actually want us to give as the final answer? The outcome. Okay. Okay, that was part 1. Just hide that all. Okay, part 2. So we want to do 4 E attack power in count, start from 4. If get rounds. So in get rounds, we need to refresh grid. Get a fresh grid. Everything's refreshed. Ah. Return. We have to return a bunch of things. Well, these variables will be... we'll return them. The round. Okay. For E, attack power. Success. So we want true if all the elves stayed alive. Yep. And round equals get round with that attack power. If success, then we calculate outcome as before. Plus that. Print outcome and break out of this loop. Get round. Get rounds. Is that gonna work? I've changed a lot of things in one big go. Starting HP equals 2, G attack power is 3. We're starting with E's 4. So what we did before was with attack power being 3. So now we're giving E more attack power. G, the goblins won. So we keep increasing it until the elves win. Not only do they win, but they don't lose any units. And let's also print the grid as well, just to see what it looks like. M equals length, refresh grid. Grid is empty list with open.text R as F. What's wrong with that? Fresh grid. Grid 0. Grid's empty. With open, it should be okay to open input a second time. Fresh grid. Damn it. Every time we call refresh grid, it should just open text again. What is it? Is it keeping a file line pointer to the end of the file? Because when with resolves, it should forget it ever opened input, and next time you open it, it should start from the beginning again. Oh, I don't understand how this works. So the first time we do it, we get 32. Oh, grid is a local variable here. That makes sense. Global grid. Make it a global variable. It's creating a new variable called grid instead of using the one we want here. It should do the same for goblins and elves. It's naughty stuff. You're not supposed to use globals. It's bad practice. Alright. Let's try that. Okay, we don't need to print. Stop printing. But that's good. It's the same grid every time. That's what we want. Alright, go. So now it's increasing. There we go. So now the elves win. 41804. I mean, the map looks good. All the elves. Is it all the elves? We'll check. Okay. Oh, okay. That was a good problem. It was nothing novel. I've done so many problems similar to that. That's basic game programming. You know, you have units, they have pathfinding, they have AI, they have HP, they have attack strength. But I mean, it's good practice because clearly I've not mastered it because I made so many errors. But that's why you need to keep practicing it. Now time for day 16, it shouldn't take 4 hours. Let me have a look at the stats again, because I think we were predicting this, weren't we? What did I say last time? This was day 15. Day 15, yeah. There was a huge drop in completions that day, going from 14 to 15. So that was an indication that we weren't the only ones. But there was also a low number here, meaning most people who solved part 1 were also able to solve part 2, which makes sense, because part 2 is really just rerun your program until the elves win, just keep increasing their attack strength. So that's... But yeah, part 1 is... But there's nothing algorithmically hard there. Like, anyone who makes pathfinding in games does the same stuff. It's just... This emphasizes how important it is to not do what I did and just write all your pathfinding and map handling all into one big huge for loop. Every time I found an error, I separated out. I made a new class for elves and goblins. I made a new class for handling. So I had a method for BFS. I had a method for getting neighbors off a position. I had a method for cleaning out the grid. I had a class for unit. as the more I separated out all these methods and classes into their own thing, the more reliable this became, which is what you'd expect, but But yeah, I mean, the end result is basically a game, a playable game, where you're not actually controlling the goblins and elves, but you choose their starting positions and let them fight. Alright, well, we can take a very, very quick sneak peek at problem 16. Oh, it's our favorite, assembly code. With ands and ors. Oh yeah, fun stuff. I mean, I always get scared of this stuff, but I don't hate this stuff as much as some other people do. I've seen some people in Advent of Code, they absolutely despise the assembly code stuff, and sometimes they just refuse to do it. I don't mind it so much, although as soon as I see it come up, I'm like, oh dear, it's more assembly code, but I don't find it that bad. This looks quite complex. We've got lots of different operations. Alright, well, we'll deal with this next time. What did the people think? So that's 16. Easier than today's problem. So, okay. It probably won't be so bad then. I mean, from this point on, the difficulty is somewhat steady, it seems, just... which is a good sign. Alright. That was 3.5 hours on 2 problems. That's not too bad, actually. 14 and 15. Averaged out almost 2 hours each. I mean, when I did the live competitions, 2020 and 2021, whatever, there were problems which took me several hours on one day. So far, I've not hit that problem for any of these. It's always been, say, 2 hours at most. But I've definitely noticed that Eric has been slipping harder problems into his competition in the recent years than previous ones, so... For all we know, Eric could be watching the stream right now. He has popped into my chat once before. So if you have anything to say to Eric about these problems, you can put a message for him in chat, but I don't think he's in chat right now. Alright, yeah, I probably have time tomorrow to carry on. I'm very hungry now. It's almost 10 PM. I haven't had dinner yet. Alright. Thank you for watching. That was problem 15. So tomorrow's problem is 16. And that'll mean about 9 problems left altogether. Thanks for watching. Bye-bye.